Hey everybody. I've decided for this one, this homework, 540 to 543. It's funny, it's all homework now, isn't it? But anyway, for this particular set of problems, I decided to create a quick video just running through the answers here. Every now and then I'll do this. Other times I'll just post my answers. But for this one, I thought I'd like to just kind of explain a few things, and here we go. Okay, so for 540. Letter A, it appeared to me that each input was being multiplied by 3. B, the next two terms I got were 162 and 486. And then for C, the next four terms were the ones in red here, 1545, 135, and 405. For the next one, I actually combined a few different problems. So 541, 1 and 2, and 543. So here we go. Voila. All right, so basically, I actually printed out the teacher resource. You can do that yourself too if you have a printer at home. And I have my answers right here in purple. Hopefully you can see them. All right, so for A, so this is the pattern on all of these. You can see I decided that was arithmetic, and my next three terms were 8, 11, and 14. And then what I did in terms of finding the pattern is I wrote it above each one. Right? I'm not going to read through all of these for you. You can read that yourself. I'll actually post this document as well as the video so you can have both of them as a resource. I do want to point out letter E is the Fibonacci sequence for those of you who did a little work on that. And I also want to point out, let me scroll down a little bit. G and H, this comes up in another problem, but the question is, are those considered geometric? And they are. If you think about this, this makes sense, right? For G, it's like, well, for G, they're dividing by 2. How's that geometric? Well, division is multiplication. I think about that for a second, and I'm sure some of you kind of get this. I multiplied by half. Well, multiplying by 1/2 is the same as dividing by 2. So anytime you're dividing, you can consider that a multiplication problem. Just like anytime you're subtracting, you can consider that also a type of addition problem. You're adding a negative. So same, they're sort of interchangeable. All right, letter I had some trouble with. I ended up graphing it first. And then I'm like, oh, this is a quadratic. All right, so the actual equation for that one would be y equals 2x squared, where I actually looked at the 0 as being term 0. The 2, one of them is the term -1, and one of them is the term 1. Right? We'll be getting a lot more into quadratics later, but hopefully that made sense to some of you. If you actually plugged into Desmos graphing calculator y equals x squared, you would actually see the quadratic that forms. Of course, these are all discrete. Discrete and continuous. So if I plugged in the equation, that would be continuous. But still, even though this would be discrete, if you were just plugging in the points, it's still a quadratic function. All right, let me scroll down a little bit more. All right, this would be 542, number 1. And these are the groupings I made. I made an arithmetic grouping, a geometric grouping, and one that is neither. All right, now you may have grouped yours differently. Don't worry about it. I'd actually be really interested to see that. If you group them differently, how did you do it? All right. All right, now, last part. Guys, I want you to use Desmos graphing calculator for this. All right, so if you look, I'm going to go over here to Desmos graphing calculator. This plus button here, this is where you click on table, and I've got a new one here, and you can just plug in a table. All right, I already did this one here. This is just a sample. Once you plug in a table, you actually get a little magnifying button down here. If you click that, it brings up the graph in such a way that you can see all the points, right? And then I just took a clip of this and pasted it onto my document, and a clip of this and pasted it onto my document. It took me a while to do all of them, But I'd still want you to do all of them because you can actually see how each table uh, creates either a linear graph or a nonlinear graph. I will say this quick reminder, the arithmetic sequences create linear graphs because they're linear functions, right? I'm going to go back to my homework here. And these, where you're multiplying by the same amount each time, like this one you multiply by 2, those create exponential graphs because they're exponential functions. And then this one here is actually a quadratic. I should have started this over here with 0. It would have made a lot more sense. But basically what's happening is the squares are, the terms are squared. That's a quadratic, not an exponential. Again, we'll be talking about those later. All right, so I'm going to scroll down. You can kind of look at mine. I'm going to be posting this document eventually as well as the video. I'm just going to post the video today. I want you to try this on your own, and then I will post the video tomorrow. All right, so good luck with this assignment. You have 2 days to do it because it takes a while to do this. All right, and I hope you have a good day.